Okay, good morning, students. So, in the last class, we're discussing about the different theorems like superposition theorem, Thevenin's theorem, and Norton's theorem, and how we can apply all the theorems and how we can find the current through any particular element by using different procedures of theorems. And in today's class, we're discussing about the transient response of series RL and RC circuit. Transient response of series RL circuit. So see here transient response of series RL. So here there are two types. One is the series RL and second one is the series RC. So in generally, so let us take we are taking any one of the series RL circuit. So suppose I'm taking this is the so here this is a switch and one resistance in series with one inductance. So it is connected across a source, voltage source. This is the V, and suppose this switch is represented by K and this is the R. So here this is the inductance L. So in generally the transition takes place at an instant t equal to 0. So but before the transition switch, here the switch K is kept open for a long time. So but after some time at t is greater than or equal to 0. So here at t is greater t equal to 0. So here at t is equal to 0, the switch K is open. Switch K is open. So here as the voltage is not applied to the series RL circuit, so here the current is also equal to 0. But after some time at t is greater than or equal to 0, the switch K is closed. Switch K is closed. So when the switch K is closed, then the current will be flows and the current will be flowing. So after closing this switch, the circuit will becomes. So here the switch is closed. Again, we just this is the K resistance R, and this is the inductance L, and here one voltage source is there, R, L, and voltage source. Here one current is flowing, that is current I. So now we just apply mesh analysis to the above circuit. Apply mesh analysis to the above circuit. So then we get, so here V, R and L. So here V is equals to I into R plus for inductance, that is the L into di by dt. So by applying we get V equal to I into R plus L into di by dt. So that is, so what we are getting the equation, once again I draw this, V equal to IR plus L into di by dt. So that is V is equals to I into R plus L into di by dt. So now I divide with L on both sides. Now divide with L on both sides. So after dividing with L both sides, then we get V by L is equals to I into R by L plus L into di by dt by L. So see here this L will be cancelled, and then we get the equation as V by L is equals to, so I am changing this equation as R by L into I plus this is the di by dt. So I am redraw this equation as di by dt plus R by L I is equals to V by L. Okay, so you just time redraw this circuit. So suppose assume this as a equation 1. So see here, this equation 1 is in the form of dy by dx plus p of y is equals to q. Now the equation 1 is in the form of, now the equation 1 is in the form of dy by dx plus p of y is equals to q. So see here, the equation 1 is in the form of dy by dx plus p of y is equals to q. So so here q is q of y, we are some assuming. So q or q of y, or simply we are taking q is enough. So dy by dx plus v of y equal to q. So this is the equation 2. So here this is the differential equation, and the solutions of this type of differential equation, the solutions of the above differential equation, the solutions of the above differential equation, mostly we are getting in the mathematics like these equations. So the solutions of the above differential equations is given by, so see here the equation is given by, so y into e power integration of p dx is equals to integration of q into e power integration of p dx plus some constant k. So this is the solution of this type of a differential equation. So now we just compare equation 1 and equation 2. Compare equation 1 and equation 2. So by comparing equation 1 and 2, what we are getting? So here di by dt, but here dy by dx. So by comparing equation 2 with equation 1, so then we get the value of y. Y is equals to I. So in place of here this is a y, and here this is a I. So in place of y there is a I. And next in place of x, so in place of x that is equal to t, and in place of p, so p is equals to r by l. And by comparing the value of q, q is equals to v by l. So by comparing equation 1 and 2, we get y equal to I, x equal to t, p equal to r by l, and q is equals to v by l. So you just substitute these values in this equation. So then we get, so first one ఏంటిది మనకు equation, that is y into e power integration of p dx. So here what is the value of y? Y is nothing but I into e power integration of p dx. What is the value of p? So here p is the r by l. So p is r by l into dx, x is the t, is equals to integration of, so next integration of e, so v by l, e integration, e power integration of r by l into dt plus constant k. So I into e power integration of p dx means r by l into dt is equals to integration of q. What is the value of q? Q is the v by l. So e power integration of again p dx. So p dx is nothing but r by l into dt plus some constant k. So by simplifying the above equations, we get, so that is I into e power, so in the e power integration of r by l into t. So here integration of r by l is constant, then integration of dt is equals to integration of v by l into e power, here also r by l into integration of dt plus k. Okay, so here I into e power r by l into t is equals to, so this v by l is constant, so that should be taken outside, then v by l is equals to integration of e power r by l into t plus constant k. Okay, so now we just take this equation as, again simplifying this equation. So here I into e power r by l into t is equals to, so here this is the v by l into v by l integration of e power r by l into t plus constant k. So that is v by l into, again you just apply the integration. So here it is in the form of integration of e power ax. So that is integration of e power ax by a. So by applying the integration we get e power r by l into t by ax, means here this is the r by l plus constant k. So see here this L will be cancelled. Then finally we get I into e power r by l into t is equals to, so here not this L. See here these two L's are cancelled. So this is the r by l into t. R by L into T. So L cancel, and then finally we get I into e power R by L into T is equals to, see here V, and in the denominator that is the R. So V by R into e power R by L into T plus constant K. So here we are getting this. So now divide the above equation with e power R by L into T on both sides. Divide with e power r by l into t on both sides. So then we get, so by dividing we get LHS is the I into e power r by l into t by I into e power r by l into t is equals to, so here v by r into e power r by l into t by, again divide with e power r by l into t plus constant k, so which is also divided by e power r by l into t. So here these two are cancelled, this also cancel, and finally we get here I is equals to, so these two are cancelled, then v by r plus, this is the k by e power r by l into t, so which is taken into that side, then k into e power minus r by l into t. So we are taking this equation as a number, this is the suppose equation 3. So initially we get I is equals to 0 and t is also equal to 0. By substituting this value we get 0, I is the 0, then v by r plus k into, in place of 0 then it is value is also equal to 1. So therefore k is equals to minus v by r. K is equals to minus v by r. So now substitute the value of k, substitute the value of k in that equation. So then we get, substitute this value of k. So by substituting that value we get I is equals to v by r. See here by substituting we get I is equals to v by r plus, so ఇక్కడ మనకు మైనస్ వచ్చింది కాబట్టి దట్ ఈస్ మైనస్ v by r into e power minus r by l into t. So v by r minus v by r into e power minus r by l into t. So from this we just take the v by r as a constant, v by r as a common, then we get v by r of 1 minus e power minus r by l into t. So this is the equation. So I is equals to v by r of 1 minus e power minus r by l into t. So this is the total current equation. Suppose if we are simplifying further, so here we are taking tau. So tau, here tau is nothing but L by r. So by substituting this, we can write this equation as I is equals to v by r into 1 minus e power minus t by tau. So we are taking different values of taus also we can simplify. Suppose we are taking at t equal to tau. So in place of t we just substitute the tau value. Then the equation will becomes I is equals to v by r. So I equal to v by r minus, so that is the e power minus t by tau means that is e power minus 1. So v by r into this is the 1 minus e power minus 1. So then we get I value, I is equals to v by r into, so here this value will becomes v by r 1 minus or e power minus 1 value. So by substituting that value, so that is a, so here the total this value will becomes I is equals to 0.632 v by r. So when t is equals to tau. So in the same way, suppose if we are taking t equal to 2 tau or t equal to 3 tau also, then also we get some different values. So here we get the current equation I is equals to v by r of 1 minus e power minus r by l into t. So this is the total equation for current in transient response of series RL circuit. And suppose if we are taking the graph for this, then we get like this. So initially this is the, suppose we are taking current I of t, and here this is the time. So here 0, the times may be t, tau, 2 tau, 3 tau, 4 tau, like this. So it is increases like this. So here this is the maximum value. Okay, so this is the transient response of series RL circuit. So in the same way, we just find the transient response of series RC circuit. Okay, so transient response of series RC circuit. So here also consider a series RC circuit, and initially the switch is kept open for a long time. So like this. So here also we just consider this is the switch, and here series RC, one resistance which is connected in series with a resistance, and that should be connected across a voltage source V. So this is the C R, and this is the voltage source. So here at t equals to 0, the switch K is open. The switch K is open. So then when it is open, we get the voltage V naught is equals to 0, and at t is greater than or equal to 0, switch K is closed. So here the switch K is closed. So after closing the switch, the circuit will be like this. So here one resistance and one capacitance, and that should be connected across a voltage source. So this is the R, C, and this is the voltage V. So now it is a closed, so some current will be flowing. So again we just apply Kirchhoff voltage law to the above circuit. So then we get the equation will be, so by applying a mesh analysis to the above circuit, then the equation will becomes V is equals to R. So I into R plus C. So for C, capacitance 1 by C into integration of I dt. So by applying mesh analysis to the above circuit, we get V is equals to I into R plus 1 by C integration of I dt. So now differentiate the above equation with respect to t. Now differentiate the above equation with respect to t. So by differentiating, we get the value V, that is a constant, is equals to 0 plus R into di by dt r into, so here the values are, so r into di by dt plus 1 by c integration of I dt, that means I. So r into di by dt plus 1 by c into I. So by simplifying this equation, we can also write it as r into di by dt plus I by c is equals to 0, is equals to 0. So this is the equation. By differentiating this equation we get. So now for this equation, so for this equation we divide with r on both sides. So then we get, so already what we are getting in the previous equation, that is r into di by dt, r into di by dt plus I by c is equals to 0. So now divide with r on both sides. Now divide with r. So then we get r into di by dt by r plus, so here I by c, so just I am writing that is a 1 by c or I by c into divide with r. So I by c r is equals to 0. So r is cancelled. So I am writing this equation as di by dt plus, so here this I, this equation can be written as 1 by RC into I is equals to 0. So we just treat this equation as a 1. So di by dt plus 1 by RC of I equals to 0. So this is also a one type of differential equation. So it is also a differential equation, and these type of differential equation having the solutions. So here the solutions of this type of differential equations is given by I is equals to C into e power minus t by RC. So let us assume this as a equation 2. So solutions of above differential equation. Solutions of above differential equation is given by I is equals to C into e power minus t by RC. So now initially at t equals to 0. So at t equals to 0, the switch K is closed. So according to Ohm's law, we can write this equation as I is equals to V by R. So that equation is V by R is equals to I. What is the value of I? I is equals to C into e power, so minus t by RC. So then we get, by substituting that, we get value of C is equals to here V by R. So substitute the value of this in equation 2. So then we get, substitute in equation 2. So by substituting we get I is equals to, so what is the value of C? So that is the V by R into e power minus t by RC. So that is the total current. I is equals to V by R into e power minus t by RC. So in this circuit we are also going to find the voltage across the resistor, and voltage across the resistor, and voltage across the capacitor, and power across the resistor, and power across the capacitor is also we need to find. So here this is the total current I is equals to V by R into e power minus t by RC. So now we are going to find the voltage across the resistance. Voltage across the resistance. Voltage across the resistance is given by, so voltage across the resistance is represented by some VR. Okay, voltage across the resistance is represented by VR. So what is the formula to find the voltage across the resistance VR? VR is equals to R into I. So that equals to R into I. Already we are getting the value of I. So what is the I? So I is equals to V by R into e power minus t by RC. So that equals to into V by R into e power minus t by RC. So here we get this R cancel. So therefore VR is equals to V into e power minus t by RC. So that is the voltage across the resistor. Okay. Next, voltage across the capacitor. Voltage across the capacitor. So that is, we can represent that as a VC. Voltage across the resistor is VR and voltage across the capacitor is VC. So how can we find the voltage across the capacitor? So the formula is 1 by C integration of I into dt. Again substitute here. So this is the 1 by C integration of I. What is the value of I? I already we are getting as V by R into e power minus t by RC into dt. So here this V by R is a constant. So that V by R is taken outside. Then we get that is V by RC. Okay. V by RC integration of e power minus t by RC into dt. So we just apply the integration. So apply the integration, then we get, so here this is the V by RC is the constant. So again you just write this V by RC, and this is the e power minus t by RC by minus RC plus some constant C. So this is the minus 1 by RC. So these two are cancelled. So then we get VC is equals to minus V into e power minus t by RC plus C. So this is the voltage across the capacitor. So first one is the voltage across the resistor and second one is the voltage across the capacitor. So in the same similar way, we just find the power across the resistor and power across the capacitor is also. Next one is the power across the resistor. Power across the resistor. So that can be we are treating as PR. Okay, power across the resistor. So what is the formula for PR? Power across the resistor, PR is equals to VR into I. So therefore substitute here. So VR is nothing but what we are getting, voltage across the resistor VR. VR is getting as V into e power minus t by RC. So this is already we are getting in the previous VR. So VR is equals to, where it is, this is the VR. VR equals to V into e power minus t by RC. So V into e power minus t by RC. And already we get I also. What is the value of I? So I is the here V by R into e power minus t by RC. By multiplying this, we get V into V by R, means V square by R into e power minus TRC into e power minus TRC, that is e power minus 2t by RC. So that is the power across the resistor. So in the same way, power across the capacitor. Power across the capacitor is given by, so which is represented by PC. We are taking power across the capacitor. So how we can find the power across the capacitor? PC is equals to VC into I. So means voltage across the capacitor into current. So what is we are getting, voltage across the capacitor minus V into e power minus t by RC into again current. What about current? Current is the V by R into e power minus t by RC. So again minus V square by R into e power minus 2t by RC. So this is the power across the capacitor and this is the power across the resistor. Okay. So this is the transient response of series RL and RC circuit. Okay. So in the next class, we are discussing one more topic. So here in this transient response of series RL and RC circuit, we just find the equations of current, and for RC circuit, we just find the equation of current as well as voltage across the resistor and voltage across the capacitor, and power across the resistor and power across the capacitor. Okay, thank you.